At the beginning of the course, we studied functions. We realized that functions have to meet certain criteria to be called functions. Nevertheless, there is another kind of relation that we kind of hinted at the time when we saw functions, but we didn't study. These are formally described as relations. So in this module, we will study relations and their properties. If you remember from the example we used at the time with the Starfleet Academy, where we had the Captain Picard and his crew and taking a course, and then we had the final grades for each of those students in the course. And we said there's a mapping in between the student and the final grade. We said that that kind of mapping, as we have it here, it was not a function. And the reason why this kind of mapping is not a function is because this is not a one-to-one function. Because, for example, we have Riker and Worf. Both of them got a C. So it is possible to go in this direction, but it is impossible to go in the opposite direction. With relations, we have a formal way of representing this kind of relationship. So when we have a set, two sets, A and B, we have a binary relation from A to B as a subset of the cross product between the two. Remember that with cross products, we come up with pairs of elements, ordered pairs. So if you're looking at a two-dimensional space, and then you have your x and your y axis, then you have a cross product between the elements of the set of the elements of the x-axis against the set of the elements on the y-axis. So to say whether an element of A is related to B, we use this notation. This means that there is a relation that maps from A to B. So note here that the order is important. So ARB is different from BRA. And to say that A is not related to B, we use that notation. So if we go back to our example with the Starfleet Academy, we see that we can represent this relationship using this kind of diagram, which is kind of a matrix. So you have, on the rows you have the students, on the columns you have the grades, and you mark with an X the corresponding places where there is a relationship. If we wanted to compare functions and relations, because this generates some confusion, here is this table. It should clarify the main differences between functions and relations. And if you think about functions, remember that exactly one element of B is assigned to A. So that means that no two students can get the same grade. Okay. So with a function, you cannot represent the Starfleet Academy example. Okay. With a relation, you can. So you may or may not have that two students got the same grade. So the one-to-many relationship between A and B is impossible to be represented using a function, but you can represent it using a relation. During the synchronous session, we'll do some exercises to reinforce these concepts. Now, if you consider that you will create relations on the same set. So before we were talking about relations between A and B sets. Now is on the same set A. There is there are 2 to the power n squared different relations on that set. Now let's take a look at the properties of relations, and again consider a relation on a set A. So it's the same set, A on A. We say that this relation is reflexive if every element is related to itself, or there is a relation between every element to itself. Okay? We say that it's symmetric if B is related to A, then also A is related to B. Remember, when we studied the conditional and the implication, we said that when you have these whenever, that means if you have Q whenever P, that means P implies Q, right? So we can rewrite this as if A, B is in R, then B, A is in R. And then we also say that a relation is antisymmetric if when you have that A, B are in the relation, then B, A is not in the relation, right? In the next set of notes, we'll see ways of representing relations, and these concepts of symmetric and antisymmetric will become much more clear. We also say that a relation on the set A is transitive if you have a relation AB and then BC. You must also have that A is related to C.